Hello dear friends, welcome to the lecture of geometry. In this lecture we shall solve some multiple choice questions on solid geometry, and these questions are on the chapters of plane, right line, sphere, cones and cylinders, and also conicoids. So I have written few questions here. We shall attempt these one by one. The first is the angle between the planes 2x minus y plus z is equal to 6 and x plus y plus 2z is equal to 7 is which one? And these are the four alternatives. So actually this is a standard result that we have, and that angle is given by cos theta. Cos theta is equal to AA1 plus BB1 plus CC1 divided by under root of summation of a square under root of summation of a1 square. So what does it mean? A, B, C are these coefficients of x, y, z in the first equation. A1, B1, C1 are coefficients of x, y, z in the second equation, and then the formula is actually the angle between the plane is same as the angle between their normals, and therefore we have to use this formula and see the value of A is 2, A1 is 1. So therefore this will be 2 into 1, that is 2. Minus 1 into 1, that is minus 1, and 1 into 2, that is again 2. So this will be the numerator, a into a1, etc. And what does it mean? Root of sigma a square means summation of a square plus b square plus c square. That is the expression for summation of a square. And what are the values of a, b, c? 2, minus 1 and 1, and sum of square. 2 square is 4, this minus 1 square is 1, and again 1 square is 1. So 4 plus 1 plus 1, that is root of 6. And here the coefficients are 1, 1, 2. That means of the same expression will be obtained. 1 square plus 1 square plus 2 square, again it is root 6. So this is according to the formula. And you see this is 1 plus 2, that is 3, and root 6 into root 6 is 6. So it becomes 3 by 6, or which is equal to half. So cos theta is equal to half. What is the angle theta? So we know that cos of 60 is 1 by 2, and that means 60 degree means pi by 3, and therefore the correct alternative is this B. The next question is any point on the line, this line, symmetric form, is given by which expression? A point on the line is given by which expression? And general point actually it is asked, and therefore we shall suppose this symmetric equation is equal to some quantity r. And if we equate this quantity equal to r, then see the value of x can be obtained by equating the first ratio to r. We take this L on the right side, that will be L into R, and then take alpha on that side, that will be alpha plus L into R. And similarly equate this ratio to R, we will get y is equal to beta plus m into R, and z is equal to gamma plus n into R. So therefore general point is given by the expression this one, alpha plus LR plus comma beta plus m into R and gamma plus n into R. So this we have done while solving the problems on right line. Now the next question is center of the sphere. See, this is the equation of sphere, and we are asked to find the center of that sphere. Actually the equation of a sphere in general form can be written like this. X square, it is for the third. The equation of sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. This is the equation of sphere, general equation. And then its center is given by, center is, see, this is minus u, minus v, minus w. So these are the coordinates of center, where what is u? 2u is the coefficient of x, 2v is coefficient of y, 2w is coefficient of z, and radius is given by under root of u square plus v square plus w square, sum of squares of these xyz coordinates of center minus d. That is the expression for radius. So you should remember the equation of sphere. If the equation of sphere is in this form, then its center is given by this and radius is given by this expression. Now if you compare this with, or the simple way to obtain the center is, see what is the value of 2u? 2u is minus 4, comparing with this, and therefore what will be u? U will be minus 2 and minus u will be 2. So this its center will become negative, or simply if the equation is in general form, divide the coefficient of x by minus 2, because if you divide this by minus 2 we get minus u, divide by minus 2 we get minus v, and divide the coefficient of z by minus 2 we get minus w. So if you divide this coefficient by minus 2 we get 2, divide the coefficient of y by minus 2 we get minus 3, and divide the coefficient of z, which is minus 8, by minus 2 we get 4. So this is the center by this formula. Radius is not asked, but radius we can obtain in the similar way. The radius will be under root of 2 square, that is 4, plus this 3 square is 9, 4 plus 9 13 plus 16, that will be 29, 29 minus d, and that will be root of 21. You may verify this. So it is not asked here, the center. So the coordinates correct are this one, 2, minus 3 and 4. So this you should remember about sphere. Now the next is, a great circle is the section of a sphere. Section of a sphere by a plane passing through which point of the sphere, that is asked. And now see, section of sphere by a plane, that we have to consider. So suppose this is a sphere, and its a section, plane section is to be taken, section by a plane. And if you see, a section of this sphere by a plane will be a circle obtained here. Actually this is the circle like this. If you cut a sphere by a plane, we will get this intersection or section of the sphere by the plane. And great circle, the way which will be the great circle, if you go on up to here at the center of the sphere and take a section of the sphere by a plane passing through the center, and see that we will get this as the circle. It is a circle, and this circle is known as great circle. So if this plane is perpendicular to this say some axis that we can consider, and then it is the section is taken like this, the plane, and the section of a sphere by a plane gives a circle, and if the plane passes through the center, then we will get a greater circle, or that is known as great circle. Great circle, and it passes through center. So the section of sphere by a plane passing through the center of the sphere is great circle. So this circle is bigger circle, and if you go on upward, we will get, or downward, we will get smaller circles. So that is the meaning of great circle. The next question is, the condition that the plane Lx plus My plus Nz is equal to P may touch the conicoid is. Now this is a theory part, that is a condition of tangency, that this plane will touch this conicoid solid object, and that touch at a single point. So that condition is given by C, this L square by A plus M square by B plus N square by C is equal to P square. So this is the correct alternative. This is the condition of actually the tangency of the plane with this conicoid. The next question is two planes, general form ax plus etc. and are perpendicular if which condition is to be satisfied. Now we know the two planes are, if the two planes are perpendicular, their normals are also perpendicular. And what is the condition of perpendicularity of normals? Here A, B, C are the DRS of the normal, and A1, B1, C1 are the DRS of the normal to the second plane. And if these two are perpendicular, the condition of perpendicular is their sum of product of the DRS is 0. That means A into A1 plus B into B1 plus C into C1 must be equal to 0, and that is the C condition. The next is the locus of the points of intersection of two spheres. So intersection of two spheres means it will be of this kind. This is one sphere and another sphere intersects this sphere. So here what will be the intersection? And the intersection of these two spheres is a circle. If the two, you have to imagine this, two circles intersect, then the intersection is a sphere, is a circle. This is a circle. Intersection is a circle. So that is the alternative C. And this is the intersection of two spheres. Now these are the next questions. The 8th one is the equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. This is a sphere. It represents a sphere. We have just earlier written standard equation of the sphere or general equation of sphere. And what should be the condition? Yeah, if it will represent a sphere, if this is having which condition, this must satisfy which condition. So what actually is this? We have earlier written that this the radius of the sphere is under root of this, and that means this is r square. This is equal to radius square, and radius square of a sphere must be what? 0 or negative, 0, positive. For a real sphere, the radius must be positive, and if it is 0, then the sphere will be only a point. Radius will never be negative, and therefore here the alternative must be radius square must be positive. The next question is about a right circular cone. If a right circular cone has three mutually perpendicular generators, then the semi-vertical angle is. So right circular cone is generated by a line which makes fixed angle with a given line, or that is the axis. See, if this is the axis and if this is the line, and if this is known as semi-vertical angle, so that may be denoted by alpha or theta. And if this line is rotated about this fixed line which is axis, so this is axis, then we will get a cone like this, and this cone is known as right circular cone. This line is rotated, and therefore this line is known as generator. And if this has right circular cone has three mutually perpendicular generators, then the semi-vertical angle, that means this alpha, is which one of these? Cot inverse of root 2, tan inverse of root 2, etc. And the result is, for this, by the equation of right circular cone, this must be tan inverse of root 2. And then further, the next question is about the same right circular cone. The semi-vertical angle of a right circular cone, this type of angle, having set of three mutually perpendicular tangent planes. So this cone has three tangent planes which are tangent to this cone, and the planes are mutually perpendicular. So in that case, the semi-vertical angle must be which one of this? And the result about this is the angle must be tan inverse of 1 by root 2. So you should remember for these two questions as here what is a mutually perpendicular generators. Then the semi-vertical, both the results are about semi-vertical angle. If the cone has three mutually perpendicular generators, this is generator, this line. Then the semi-vertical angle is tan inverse of root 2. And if the cone has three mutually perpendicular tangent planes, then the semi-vertical angle is tan inverse of 1 by root 2. That is the difference in these two results. So you should remember these two. The next is the intercept of z-axis. The intercept on the z-axis of this plane is, now this is simple. To get the intercept on any axis, we have to put the remaining coordinates 0, because on z-axis x is 0, y is 0, and therefore if x is 0, y is 0, this is to be deleted, and what remains, 2z is equal to 2. This gives z is equal to 1, and therefore the intercept is 1. Similarly, if we are asked to find x-intercept, then put y and z is equal to 0, then x is equal to 2 is the x-intercept of this plane, and similarly you can get y-intercept. The next is the line. This is symmetric form of line, is parallel to which plane? Now see, the line and plane are parallel. So this is a line and this is a plane. So these two are parallel. If these two are parallel, what about the relation between normal? Normal is perpendicular line to the plane. So this is normal. So this line, normal to the plane, is also perpendicular to the line. And therefore, the line must be perpendicular to the normal of the plane. And what are the DRS of the normal to the planes? The coefficients of x, y, z are the DRS of normals to the plane. For the first plane, they are 2, 1, minus 2. For the next, 3, 4, 5, etc. And if they are perpendicular, they must satisfy the condition of perpendicularity. That means the sum of product of the DRS must be equal to 0. The DRS of the line are 3, 4, 5. These are the DRS of the line. And therefore, the product of 3, 4, 5 respectively with the DRS and its sum is 0. So, which will result it? Now, if you consider C, it's 3 into 2, that is 6. So, 3 into 2, then plus 4 into 1, here it is 1, and plus 5 into minus 2. So, what is the resulting value? See, it is 6 plus 4 is 10, minus 10 is 0. So, therefore, it satisfies by the first plane. Its normal is perpendicular to the line, and therefore, this is the correct alternative. So, in this way, we have to check the condition of perpendicularity, and remaining will not satisfy this. 3 into 3 plus 4 into 4 plus 5 into 5, it is not 0. And now the next question is section of a right circular cylinder by any plane perpendicular to its axis. Right circular cylinder, see, this is right circular cone, and right circular cylinder is see this this type of figure it is, and this is right circular cylinder. Its axis is this one. And what is asked about this is right section of right circular cylinder by a plane perpendicular to its axis. Plane must be perpendicular to the axis. That means this type of plane will be there. And its section what will be its section? If you cut the cylinder like this, then obviously we will get a circle here, just as the top, like this. We'll get, if you take the intersections, every intersection, if the plane is perpendicular, condition is the plane must be perpendicular to the axis. Then every time we get a section which is a circle, but that the options are a sphere, a normal section, a plane, a triangle, and that section is known as normal section because it is perpendicular. So perpendicular section is known as normal section. It is actually a circle, but the section is known as normal section. Guiding curve of a right circular cylinder is which one? So right circular cylinder is generated by this. So see, it by a intersecting line to a circle. The line is intersecting and parallel to the plane of the circle. So this line, if this line is rotated along this circle, we will get a cylinder of this type. As like the cone, if it is rotated about this, then we will get a cone, and if this line is moved along the circle, the figure obtained is circular cylinder, right circular cylinder. So therefore this is known as guiding curve. This circle is known as guiding curve, and this line is known as generator of the right circular cone. So guiding curve of a right circular cylinder is a circle. So this is the correct alternative for this question. The next question is the point of contact of the plane Lx plus My plus Nz is equal to P, where it touch to the central conicoid Ax square plus By square plus Cz square is equal to 1 is what? The point of contact is asked. And see, if we consider alpha, beta, gamma as the point of contact, then the tangent plane can be written by replacing x square by alpha x. So that will be a alpha x, the tangent plane will be a alpha x plus y square by b, if the point of contact is alpha, beta, gamma, it is alpha, beta, gamma, then the tangent plane will be a alpha x plus b beta y plus c and gamma z is equal to 1. So this is the tangent plane, and we have to make this condition, this plane to be tangent. So these will be the both the equation will be of the same plane, and that tangent plane. So therefore comparing the coefficients, what we shall get is L upon A alpha and is equal to L upon A alpha is equal to M upon B beta is equal to N upon C gamma, and again putting that condition in this central conicoid equation. So what we shall get is the relation is L upon A alpha. So I shall write here L upon A alpha is equal to M upon B beta and is equal to N upon C gamma. And from this, what is alpha? Alpha we can obtain this condition, and is equal to 1 upon P upon 1 is equal to P upon 1, comparing these two tangent equations. And from this what we shall get is alpha value is L upon AP. So alpha is L upon AP. Equate the first ratio to the last, and beta will be, take beta on this side, P on this side, beta will be P M upon B into P, and similarly beta is M upon B into P, and gamma will be from this, take gamma on this side, P on this side, N upon Cp. So this is actually the point of contact. So what we have done is taken the point alpha, beta, gamma. This is actually theory part, and therefore the result is L upon A P, M upon comma, M upon B P, comma, N upon Cp. This is the point of contact. Next is the number of arbitrary constants in equations of a straight line is, and we have obtained this, we have studied this. The line is considered in symmetrical form. So then if the line is considered in this type of symmetrical form, then it has 4 arbitrary constants, or that means any equation of line in 3 dimensions has 4 arbitrary constants. The equation of plane in normal form is, now this is a standard result, normal form of equation of plane. So that so this is which is we call it as a intercept form. This is none of the form, this is general form, and this is the normal form, where L, M, N are actual direction cosines of the line, and P is the distance of the line from the origin, distance of the plane. Here it is plane. L, M, N are the direction cosines of the normal to the plane, and P is the distance of the plane from the origin, that is the normal form. The next question is equations of the right circular cone whose vertex is at the origin. whose vertex is at the origin, and the axis is x-axis along x-axis, and the semi-vertical angle is alpha, is what type of equation? So this is also a result, and that has see, suppose these are the coordinate axis, and the cone, if this is the x-axis, then the cone is of this type, right circular cone. Its axis is x-axis, semi-vertical angle is alpha. And in this case, the equation of the right circular cone is written as, see, y square plus z square is equal to x square tan square alpha. We should remember, when the axis is x-axis, then the term x square tan square alpha is on the right side. And if the question is for, see, this for this cone, x-axis is the axis. For y-axis, if the axis is y-axis, then the equation will be y square tan square alpha will be on the right side, and remaining terms means x square z square will be on the right side, left side. So and the semi-vertical angle is the same. So here y-axis means the cone will be of this type. Its axis is y-axis. This is y coordinate. And similarly, if the axis is z-axis, then the equation will be x square plus y square is equal to z square tan square alpha. Should remember all these results according to the axis. If the x-axis is there, x square tan square alpha is on the right side. Remaining variables y, z will be in the same form on the left side. So the correct alternative here is this one, y square plus z square is equal to x square tan square alpha for x-axis. Next, the equations of the line joining the points. So this is a straightforward and simple question. Line joining these 2 points, we can use 2-point form. So or we shall get the DRS of the line by this these coordinates of the 2 points. So 7 minus minus 2 means 7 plus 2, then minus 2 minus 4, and then 5 minus 2 are the DRS of the line. So these are the DRS of the line, or that is actually 9 minus 6 and 3, or that is we can divide it by 3. These are the proportional values, so we can reduce it, but by this in the same proportion. So if we divide it by 3, then we get 3 minus 2 and 1. So actually these are the DRS of the line, and the line passes through one of the points. So the equation in symmetrical form can be written as taking this point or this one. Anyway, we can write. And if you take the point as this point, x minus x1 means the equations will be x plus 2 divided by 3. Y minus y1, y1 is 4, minus 4 divided by second DRS 2, and is equal to z minus z1, that is 2, divided by this DRS. So this is one equation, and see, it is there is a choice, the D. Or otherwise the equations will also be written as, see, but if you take this point, then the equation can also be of the line, same line, x minus 7 divided by 3 is equal to y minus minus means plus 2, taking this point, y minus of minus 2 divided by this DRS is equal to z minus 5 divided by 1. So but this is not the alternative, so this is right one. Both of these are the equations of the line joining these 2 points, and we can use this result. Next is the distance of the plane, this plane from the origin. There is a standard result formula of distance of a plane from a point, and origin, the coordinates are 0, 0, 0, and what is the plane? Equation is 2x minus 3y plus 6z plus 14 is equal to 0. So what we have to do is we put these coordinates as x value, y value and z value, and therefore this is 0, 0, 0, and what remains is 14 divided by under root of 2 square plus minus 3 square plus 6 square, sum of squares of the coefficients of x, y, z, and that is 14 divided by, see this value is 4 plus 9, that is 13 plus 36, that is 49, root of 49, and that is 14 by 7, which is 2. So the correct alternative is 2 for this one. So here the formula is, direct formula is used. So in this way we can solve the multiple choice questions on solid geometry. So what is required to attempt multiple choice question is we have to first study the earlier content thoroughly. That means the equation of whatever it is plane or right line or sphere, etc. The terms related to these different forms of equations and simple results we have to study, and then we can attempt these type of multiple choice questions. So we shall stop here. Thank you.